Today we answer the 5 ultimate whys of the universe. We're going to peel back the fabric of reality to expose the terrifying, beautiful and flawless mechanics that keep you alive. When you look up at the night sky, you're not just looking at stars. You are watching a cosmic ballet that has been performing for nearly 14 billion years. The Earth rotates on its axis at roughly 1,000 miles per hour at the equator, giving us the cycle of day and night. The Moon orbits the Earth. The Earth orbits the Sun, hurtling through space at 67,000 miles per hour. The Sun, along with hundreds of billions of other stars, orbits the supermassive black hole at the center of the Milky Way galaxy, moving at a staggering 500,000 miles per hour. And even our galaxy is spinning as it falls toward the Andromeda galaxy, locked in a gravitational dance that will eventually end in a spectacular collision billions of years from now. From the microscopic swirling of electrons around an atomic nucleus to the macroscopic churning of superclusters spanning hundreds of millions of light years, nothing is still. The universe is obsessed with rotation. But why? Why cannot things simply exist in perfect motionless silence? To understand this, we must travel back to a time when humanity believed the exact opposite. For thousands of years, our ancestors looked at the sky and saw a dome of fixed stars rotating around a stationary Earth. The geocentric model, championed by Ptolemy and endorsed by mighty empires and religions, felt intuitively correct. The ground beneath our feet feels solid, unmoving. It was terrifying to suggest otherwise. When Nicholas Copernicus proposed that the Earth was actually spinning and orbiting the Sun, it was not just a scientific theory. It was a philosophical earthquake. It stripped humanity of its central privileged place in creation. When Galileo Galilei pointed his crude telescope at Jupiter and saw moons spinning around it, he proved that not everything revolves around us. He was threatened with torture and placed under house arrest for the rest of his life simply for stating that the universe is in motion. The realization that we are living on a spinning rock flying through a dark void was the first great trauma of modern science. But it was only the beginning of the mystery. If the Earth is spinning, what started it? And more importantly, what keeps it going? The answer lies at the very beginning of everything. Imagine a time before time, a space before space. The Big Bang was not an explosion in space, but an explosion of space itself. In those first incomprehensible fractions of a second, a period physicists call the Planck epoch, the universe was an infinitely hot, infinitely dense soup of pure energy and subatomic particles. The laws of physics as we know them did not yet exist. As this primordial plasma expanded and cooled during a period of hyper-rapid expansion, known as inflation, it was not perfectly smooth. At the quantum level, the subatomic realm is never completely still. There were microscopic quantum fluctuations, tiny random ripples in the fabric of the early cosmos. These tiny irregularities meant that matter was not distributed completely evenly. Some regions were infinitesimally denser than others. Gravity, the ultimate sculptor of the universe, immediately went to work. The denser regions began to pull in surrounding dark matter and regular matter. As matter fell inward toward these gravitational wells, it rarely fell perfectly straight down. Because the universe was a chaotic, turbulent place, expanding and cooling, the incoming gas and dust had tiny, almost imperceptible lateral motions. They carried the memory of those original random quantum tremors. Now we must introduce one of the most unbreakable laws of physics, a principle that governs everything from atoms to galaxies: the conservation of angular momentum. In the early 20th century, a brilliant mathematician named Emmy Noether proved a theorem that changed physics forever. She showed that every conservation law in nature is tied to a fundamental symmetry. The conservation of angular momentum is tied to the rotational symmetry of space, meaning the laws of physics are the same no matter which direction you face. You have seen this law in action countless times. Picture a figure skater spinning on the ice. When she extends her arms, she spins slowly, but as she pulls her arms in close to her body, her spin accelerates dramatically. She is not creating new energy. She is conserving her angular momentum. As her radius decreases, her rotational velocity must increase to keep the total momentum constant. This exact same principle governs the birth of stars. Hundreds of millions of years after the Big Bang, vast clouds of hydrogen and helium gas spanned the cosmos. As gravity pulled these primordial clouds closer together, those massive structures began to shrink. And just like the figure skater pulling in her arms, the tiny random, almost invisible lateral motions within the cloud were amplified. The cloud began to spin. As the cloud collapsed further, it spun faster and faster. Centrifugal force began to battle gravity. Gravity wanted to pull everything into a single, infinitely dense point in the center, but the sheer speed of rotation pushed the matter outward along the equator. The result was a flattened, spinning protoplanetary disk. This is why our solar system is basically flat. All the planets from Mercury to Neptune orbit the Sun in roughly the same plane because they all condensed from the same spinning disk of debris. The spin of the Earth that gives you the gentle morning breeze and the glowing sunset is not a recent invention. It is the fossilized momentum of the cloud of gas and dust that birthed our solar system 4.5 billion years ago. In the vacuum of space, there is no air friction to slow things down. The Earth keeps spinning because there is absolutely nothing to stop it. The violent, chaotic energy of that ancient collapse is still alive, coursing through the mantle of our world, driving the ocean currents and swirling the atmosphere into massive hurricanes. But the implications of this eternal valse are far more profound than just weather patterns. If the universe did not spin, if matter simply collapsed straight inward under the crush of gravity, everything would form into gigantic dead spheres. There would be no flattened disks of debris to form planets. There would be no stable orbits. Matter would simply plummet directly into the fiery hearts of giant stars and be consumed. The spin is the fundamental mechanism of creation. It is the centrifugal shield that holds matter at bay, allowing it to cool, to clump together, to form rocks, water, and eventually life. Your very existence depends on the fact that the universe cannot stand still. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of it was forged in the nuclear furnaces of dying stars that were born from spinning disks. The angular momentum of the cosmos is the heartbeat of creation. It is the relentless engine that turns dead dust into dynamic, evolving worlds. Yet when we observe the outer edges of our own spinning Milky Way galaxy, we find a terrifying anomaly. In the 1970s, an astronomer named Vera Rubin was studying how galaxies rotate. According to the laws of physics based on the visible matter, we can see the stars at the very edge of the Milky Way should be moving much slower than the stars near the center, just like Pluto orbits the Sun much slower than Mercury. But Rubin discovered something impossible. The outer stars were spinning far too fast. They were whipping around the galaxy at speeds that should have flung them out into the deep void of intergalactic space like water flying off a wet dog. But they were not flying away. Something invisible, something unimaginably massive was holding the spinning galaxy together. We call it dark matter. It is a phantom scaffolding that permeates the entire universe, making up roughly 85% of all the matter in existence. Yet it interacts with nothing but gravity. We cannot see it. We cannot touch it. But without the gravitational grip of dark matter, the eternal valse would tear galaxies apart, and the universe would be nothing but a scattered mist of lonely stars. The spin reveals the unseen skeleton of the cosmos. The universe has been spinning for 13.8 billion years without stopping, but spin alone just scatters dust into the void. To build a galaxy, to build a stable home for us, the spinning dust needed a central anchor, a force powerful enough to hold billions of stars in a delicate eternal embrace. And the universe chose the most terrifying destructive anchor imaginable. I used to think the silent void of space was the most frightening thing out there, until I realized what is lurking in the exact center of our own galactic home. Deep in the heart of the Milky Way, 26,000 light-years from where you're sitting right now, lies a region of space shrouded in thick, impenetrable clouds of cosmic dust. For decades, astronomers stared at this central bulge of our galaxy and saw only a glowing haze. It was a region of intense radiation and chaotic energy, but the visible light was blocked by millions of solar masses of interstellar soot. But humanity is relentlessly curious. When scientists developed instruments capable of peering through the dust using infrared light and radio waves, they discovered something that defied all common sense. In the late 1990s and early 2000s, teams of astronomers began tracking the motions of individual stars near the absolute center of the Milky Way. They found a cluster of stars orbiting an invisible point in space. These stars were not drifting lazily. They were whipping around this completely empty point at insane velocities, some reaching millions of miles per hour, fractions of the speed of light. The gravitational pull required to sling an entire star around like a toy on a string is incomprehensible. By painstakingly calculating the orbits of these stars over decades, astronomers realized that packed into an area smaller than our own solar system was a mass equivalent to 4 million suns. 4 million times the mass of our sun crushed into a space so small it defies the laws of classical physics. It emitted no light. It cast no reflection. It was a region where gravity was so intense that nothing, not even light itself, could escape its grip. It was a supermassive black hole. We named it Sagittarius A star. For a long time, the public and even some scientists thought of black holes simply as cosmic vacuum cleaners, roaming the dark universe and indiscriminately swallowing everything in their path. We imagined them as the ultimate destroyers, the dead ends of physics where time stops, matter is crushed out of existence, and the laws of nature break down completely at a point of infinite density known as the singularity. We feared them, but as our telescopes grew larger and our reach expanded deeper into the cosmos, we realized a shocking truth. Sagittarius A star is not an anomaly. It is the rule. Nearly every single massive galaxy we can observe, from the majestic spiral arms of Andromeda to the massive elliptical blobs in the distant universe, harbors a supermassive black hole at its core. Some are millions of times the mass of our Sun. Others are billions of times more massive. In 2019, humanity achieved the impossible. The Event Horizon Telescope, a global network of synchronized radio observatories acting as a single Earth-sized lens, captured the first actual image of a black hole's shadow in the center of the galaxy, Messier 87. It was a glowing, asymmetrical ring of fire surrounding a heart of absolute darkness. That darkness is the event horizon, the point of no return. If you were to fall toward it, the extreme gravity would warp space and time so drastically that to an outside observer you would appear to slow down and freeze at the edge forever, fading to red. But for you, time would proceed normally as you cross the threshold into the unknown, drawn inevitably toward the singularity where all known laws of physics shatter. It is a place where space and time switch roles, where the future points exclusively inward. The sheer existential terror of such an object is matched only by its vital importance to our existence. This cannot be a random coincidence. Why would the brightest, most vibrant nurseries of life and light in the universe be wrapped around the darkest, most destructive entities known to science? The answer flips our entire understanding of the cosmos upside down. Black holes are not the destroyers of galaxies. They are the architects. To understand why we have to travel back in time to the cosmic dark ages a few 100 million years after the Big Bang. The universe was filled with massive cold clouds of primordial hydrogen and helium gas. As gravity pulled these clouds together, they became denser and hotter. But to form a galaxy, a sprawling metropolis of hundreds of billions of stars, you need more than just gravity pulling gas together. You need a spark. You need an anchor to build around, and you need a mechanism to control the chaos. The very first generation of stars in the universe were monsters hundreds of times more massive than our Sun. They burned furiously and died quickly in apocalyptic supernova explosions, leaving behind the first seed black holes. In the dense, chaotic environment of the early universe, these seed black holes began to merge and consume the surrounding gas, growing exponentially. As vast amounts of matter spiraled inward toward the event horizon of these growing black holes, it did not fall straight in. It formed a swirling flattened structure called an accretion disk, driven by the very same conservation of angular momentum we talked about earlier. The friction and gravitational forces within these spinning disks were so intense that the gas heated up to millions, even billions of degrees. This superheated matter began to glow with a blinding brilliance that outshone the combined light of every star in the surrounding galaxy. We call these monstrously bright feeding black holes quasars. The radiation and the incredibly powerful magnetic winds erupting from these quasars were so fierce that they acted like cosmic blowtorches. They blasted immense jets of energy and subatomic particles millions of light years into deep space. This violent process, known as active galactic nucleus feedback, is the secret to galactic architecture. If the supermassive black hole had not been there to regulate the star formation, the early galaxy would have simply collapsed under its own weight, burned through all its gas in a furious, brilliant flash of starbirth, and died young, leaving behind a dead red cemetery of old stars. Instead, the supermassive black hole paced the growth of the galaxy. Its intense radiation heated the surrounding cold gas, temporarily shutting down star formation. Then, as the gas cooled, it fell back in, sparking a new generation of stars which fed the black hole again, creating a self-regulating cycle that lasted for billions of years. The black hole stirred the galactic pot. It ensured that the heavy elements forged in the hearts of dying stars, the carbon, oxygen, and iron necessary for life, were violently distributed throughout the galaxy, fertilizing the cold interstellar clouds that would eventually birth solar systems like ours. The monster in the dark was actually the conductor of the grand symphony. Its immense, inescapable gravity provided the central anchor for billions of stars to orbit in a delicate balance, while its violent, energetic outbursts regulated the temperature and the flow of the gas, ensuring a steady, sustainable birth of new stars over deep cosmic time. You're alive today, breathing and thinking, because a supermassive black hole orchestrated the exact thermodynamic conditions necessary for your solar system to form in a quiet, safe suburb of the Milky Way, far enough from the deadly radiation of the center, but close enough to the heavy elements it helped distribute. We owe our existence to the ultimate abyss. We are children of the black hole. These invisible leviathans built the glowing cities of stars we call galaxies. But stars do not just burn randomly. They follow a script of unimaginable precision. They fuse hydrogen into helium at a specific mathematically predictable rate. They emit specific wavelengths of light. The planets that orbit them follow precise geometric trajectories. Every atom in your body binds together following exact electrochemical rules. If the script was altered by even a fraction of a percent, the stars would never have ignited. The carbon in your DNA would never have formed. The universe would be a sterile wasteland of scattered subatomic particles. So who wrote the rules? Why does the universe follow such a flawless, intricate code? The answer to that question reveals an order so perfect it has driven some of the greatest minds in history to the brink of madness. When you look at a snowflake, a crystal of salt, or the spiraling double helix of human DNA, you're witnessing an architectural perfection that borders on the miraculous, but this perfection is not an accident. It is governed by a set of rules so deeply embedded in the fabric of reality that we rarely even acknowledge them. We call them the fundamental forces of nature. They are the invisible puppet strings that dictate every single interaction in the cosmos, from the violent collision of galaxies to the quiet firing of neurons in your brain. There are 4 of them: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. On the surface, having rules seems logical, but here is the terrifying part that keeps theoretical physicists awake at night. There is absolutely no physical reason why these forces have the exact specific strengths they do. They are just numbers, constants that seem arbitrarily tuned like dials on a grand cosmic machine. And if you reach out and turn any one of those dials just a fraction of a hair in either direction, the universe as we know it ceases to exist. Let us start with gravity. It is the force that holds your feet to the floor and binds the solar system together. Yet it is shockingly, almost laughably weak compared to the other forces. A simple tiny refrigerator magnet can easily pull a paperclip upward, overpowering the gravitational pull of the entire Earth, a rock weighing 6 septillion kilograms. The electromagnetic force of that tiny magnet is trillions of times stronger than Earth's gravity. But what if it was not? What if gravity was just a tiny bit stronger? Even a 1% increase would be catastrophic. The stars would burn far too hot and too fast. Our sun would exhaust its nuclear fuel in a few million years instead of billions dying out long before complex life ever had a chance to evolve in its warming glow. The universe itself would halt its expansion reverse course and collapse back in on itself in a fiery apocalyptic event known as the Big Crunch. Now what if gravity was just 1% weaker? Matter would never have clumped together to form stars or planets in the first place. The universe would be a cold, dark, expanding soup of lonely hydrogen atoms drifting further and further apart. You are walking on a razor-thin tightrope of gravitational perfection, but gravity is just one dial. Consider the strong nuclear force. This is the glue that binds protons and neutrons together inside the nucleus of an atom. Protons are positively charged. They want to repel each other violently, just like two north poles of a magnet. The strong force acts as a microscopic straitjacket holding them together against their will. When stars fuse hydrogen into helium, they release energy based on a very specific mathematical conversion. Exactly, 0.007 of the mass is converted into energy. If that number was 0.006, protons and neutrons would not bind at all. The universe would consist of nothing but hydrogen. No carbon, no oxygen, no planets, no you. If the number was 0.008, fusion would be too efficient. All the hydrogen in the universe would have been consumed shortly after the Big Bang in a massive flash of radiation. There would be no fuel left to light the stars, no water to fill the oceans. The balance is so precarious it is mathematically absurd. And then there is electromagnetism, the force that governs light, electricity, and chemistry. It dictates how electrons orbit the atomic nucleus. If the electromagnetic force was slightly stronger, electrons would be bound so tightly to their atoms that chemical reactions would be impossible. Life, which is essentially a continuous series of complex chemical reactions, could never occur if it were slightly weaker. Atoms could not hold on to their electrons at all. Molecules would disintegrate instantly. The building blocks of DNA would unravel into useless dust. The precision is staggering. It is as if you walked into a dark control room with millions of dials, each one controlling a different aspect of reality, and every single dial was tuned to the exact perfect, microscopic notch required to allow complex life to exist. Physicists call this the fine-tuned universe problem. It is arguably the greatest unsolved mystery in modern science. Some scientists argue it is just pure dumb luck. The weak anthropic principle suggests that if there are an infinite number of universes in a vast multiverse, each with entirely different physical laws and randomly generated constants, we just happen to live in the one that accidentally supports life, because otherwise we would not be here to observe it. It is the ultimate cosmic lottery, and we are holding the winning ticket out of trillions of dead, sterile, chaotic universes. Others see the shadow of a grand design, a mathematical beauty woven into the very fabric of space-time by something or some process we cannot yet comprehend. Albert Einstein famously said he wanted to know if God had any choice in the creation of the universe. He was not talking about religion. He was talking about necessity. Does the universe have to be this way? Could it exist in any other configuration? Right now, the math tells us that our existence is a statistical impossibility. We are suspended over an abyss of nothingness, held up only by the delicate, perfect balance of four invisible forces that demand absolute obedience from every atom in existence. The universe is not a chaotic mess. It is an elegant, balanced equation. It is a masterpiece of thermodynamic and quantum engineering. We navigate our daily lives oblivious to the fact that the stage we stand on is so precariously balanced that a single breath from the cosmos could shatter it. The rules of physics are perfect. They are symmetrical. They are beautiful. But within this perfection there is a flaw. There is one rule that breaks this beautiful symmetry, a rogue law that does not care about balance, a merciless dictator that forces everything from the grandest spinning galaxies to the fragile human heart toward a single, unavoidable and terrifying fate. While the four fundamental forces build the universe, this rogue law is actively destroying it. Have you ever dropped a glass and watched it shatter into 1,000 pieces on the floor? It is a completely normal everyday event. But have you ever seen those 1,000 pieces spontaneously leap back up from the floor and reassemble themselves into a perfect, flawless glass in your hand? Of course not. It sounds like magic or a movie played in reverse. But here is the most baffling secret of modern physics. According to the fundamental equations of motion, gravity, electromagnetism, and quantum mechanics, there is absolutely no reason why that glass could not reassemble itself. The core laws of physics are time-symmetric. They work exactly the same way whether time is moving forward or backward. If you zoom in and look at a single molecule of water bouncing off another molecule, you cannot tell if the film is playing forward or backward. The math does not care about the past or the future, so if the microscopic rules do not care about the direction of time, why does the macroscopic world we live in care so much? Why do we remember the past but not the future? Why do people age but never grow younger? Why do stars burn out and die but never unburn from ashes? The answer is entropy. Entropy is a measure of disorder or randomness in a system. And the second law of thermodynamics dictates that the total entropy of an isolated system can never decrease over time. It can only stay the same or increase. The universe has a relentless, overwhelming preference for disorder. Think of a deck of cards perfectly ordered by suit and number. There is only one way for that deck to be in perfect order, but if you shuffle it, there are unimaginably vast numbers of ways for the cards to be disordered. Statistically, the universe simply wanders toward the most probable state, and disorder is always vastly more probable than order. This is the arrow of time. Entropy is the only physical law that demands a specific direction for history. It is the invisible current of the river we're all floating on, dragging us relentlessly downstream. When the universe began in the Big Bang 13.8 billion years ago, it started in a state of unimaginably low entropy. It was highly ordered, tightly packed, and brimming with usable energy. It was like a giant, tightly wound clockwork spring. Ever since that moment, the universe has been unwinding. Every time a star shines, every time a black hole swallows a cloud of gas, every time a volcano erupts, every time you take a breath, or your heart beats a little bit of, that original order is permanently destroyed and converted into disordered waste heat. You are a biological machine that accelerates the entropy of the universe. Life itself is a desperate localized struggle against this cosmic decay. We eat food, which is highly ordered chemical energy from the sun, and we excrete heat and waste into our environment. We build magnificent cities and advanced civilizations, creating temporary islands of order, but we do so at the terrible cost of increasing the total chaos of the universe around us. We are fighting a war we are mathematically guaranteed to lose. This rogue law, this merciless dictator, guarantees that the universe will eventually die, not in a fiery explosion, but in a slow, agonizing fade to black. Billions of trillions of years from now, the last star in the cosmos will exhaust its nuclear fuel and fade into a cold, dead ember. The spectacular glowing galaxies will dissolve into the dark. The supermassive black holes will be the only things left reigning over an empty void. But even they are not immortal. Through a process called Hawking radiation, they will slowly evaporate into nothingness, particle by particle over timescales so vast they render the human mind obsolete. Eventually all matter will decay. All energy will be evenly distributed across a vast expanding void. The temperature of the entire universe will drop to absolute zero. Nothing will happen, and because nothing can happen, time itself will lose all meaning. There will be no past, no present, and no future, just an eternal silent freeze. This is the heat death of the universe, the ultimate absolute victory of entropy. Time only moves forward, dragging the entire universe toward a cold, dark end. The stars will die, the black holes will evaporate. Faced with this terrifying, meaningless void, the universe did the most extraordinary thing. Before the lights go out, before the eternal freeze sets in, the universe decided it needed to see itself. It needed to understand its own tragedy and beauty. For billions of years, the cosmos was deaf, dumb, and blind. Vast clouds of nebulae bloomed in stunning, majestic colors, but there were no eyes to see them. Supernovas erupted with the force of 1 billion suns, but there were no ears to hear the cosmic roar. The universe was an empty theatre playing a breathtaking masterpiece to rows of vacant seats. But then on a small wet rock orbiting an unremarkable yellow dwarf star, something shifted. The relentless march of entropy continued. But in the warm ancient oceans, a localized rebellion began that would change the destiny of the cosmos forever. In the warm, dark depths of the ancient oceans around hydrothermal vents, spewing volcanic heat, a localized rebellion against entropy began. Atoms of carbon, hydrogen, nitrogen, and oxygen forged in the dying breaths of ancient stars and delivered to Earth by violent asteroid impacts began to bond. They formed amino acids. They formed proteins. They formed complex replicating molecules. It was the greatest magic trick in the history of reality. It was chemistry evolving into biology. Dead matter was suddenly imbued with a desperate drive to persist and replicate. But life alone is not consciousness. A bacterium is alive. It consumes energy. It reproduces, but it does not wonder why it exists. It does not look at the stars and feel awe. It does not fear the future or regret the past. The true miracle, the final and most profound, why of our journey happened when those simple single cells began to work together. Over hundreds of millions of years of brutal, unforgiving competition and survival, the nervous system evolved. It started as simple sensory patches allowing soft-bodied organisms to detect light or poisonous chemicals in the water. Then came the spinal cords, the brain stems. The primitive reptilian brains focused solely on the cold mechanics of eating, fighting, fleeing, and mating. The universe was slowly learning to react to itself. And finally, atop this evolutionary scaffolding bloomed the neocortex, a dense, tangled wet web of 86 billion neurons firing in a synchronized electrochemical symphony inside the dark bone vault of your skull. Think about that number for a moment. 86 billion neurons, that is roughly the same number of stars in the Milky Way galaxy. You carry an entire universe of connections inside your head, and in that intricate firing network a new dimension of reality emerged. Subjective experience. You're not just a collection of random atoms, you are the universe waking up. When you look at the Andromeda galaxy through a telescope, it is not just a human looking at a galaxy. It is a piece of the universe observing another piece of the universe. When you feel awe, fear, love, or curiosity, that is the cosmos experiencing its own majesty and its own tragedy. Why do we have consciousness? Perhaps the universe governed by cold mathematical laws and the relentless march of entropy required a witness. Without a conscious mind to perceive it, the concepts of space-time beauty and math are entirely meaningless. A star does not know it is massive. A black hole does not know it is dark. Time does not know it is passing. Only we do. Consciousness is the universe bringing meaning to its own existence. We are the mechanism by which the cosmos can ask questions about itself. Every scientific discovery, every poem written, every mathematical theorem solved is a moment of cosmic self-realization. The atoms in your brain have been on a 14 billion year journey to reach this exact configuration, just so you could sit here today and understand the story of your own origin The carbon in your muscles was forged in the belly of a dying star. The iron in your blood was created in a supernova explosion. The water in your tears is older than the solar system itself, brought here by icy comets crashing into a molten Earth. It is a heavy burden and a breathtaking privilege. The same fundamental forces that crush galaxies and dictate the flow of time are currently beating in your chest and firing in your mind. The spinning disk of the early solar system is in your bones. The supermassive black hole that sculpted our galaxy paved the way for your home. The delicate balance of the four fundamental forces prevents you from disintegrating into nothingness, and the relentless flow of entropy ensures that your time here is limited, making every single second infinitely precious. You are the cosmic anomaly. You are the universe experiencing itself. But our understanding is far from complete. We've answered the 5 ultimate questions of our reality: the spin, the monster in the dark, the flawless code, the arrow of time, and the awakening mind. But what if everything we just discussed, everything we can see, touch, and measure is nothing more than a single microscopic bubble in an infinite boiling ocean of realities? We thought solving the fine-tuned universe was the end of the story. We traced our origins from the violent spin of the Big Bang to the crushing dark of supermassive black holes, and finally to the awakening of the human mind. We looked at the mathematically perfect laws of physics that allow us to exist, and we felt a sense of profound relief. We survived. We won the cosmic lottery. But the math of our own creation points to a terrifying conclusion. Our universe is not the universe. It is not the grand entirety of existence. It is just one microscopic, fragile bubble in a boiling infinite ocean of realities. Welcome to the multiverse. To understand how we're not alone, we have to go back to the exact fraction of a second when everything began. For decades, scientists believed the Big Bang was a single, isolated event, a singularity that exploded outward, creating all the space-time and matter we can ever observe. But in the 1980s, a theoretical physicist named Alan Guth realized there was a massive problem with this simple model. The universe we see today is too uniform, the temperature of the cosmic microwave background radiation. The afterglow of the Big Bang is almost exactly the same in every direction we look. If the universe just exploded normally, the different regions would not have had enough time to interact and equalize their temperatures. It would be like pouring a cup of boiling water into a bathtub of ice, and expecting the entire tub to instantly become the exact same lukewarm temperature. It violates the laws of physics. To solve this, Guth proposed the theory of cosmic inflation. He suggested that in the first infinitesimally small fraction of a second after the Big Bang, the universe did not just expand, it violently hyper-expanded at a speed vastly faster than the speed of light. It stretched out so fast and so violently that it smoothed out all the wrinkles and equalized the temperature across the cosmos before slowing down to the normal expansion rate we see today. Inflation solved the uniformity problem perfectly. The math worked, the observations matched, but then physicists realized something horrifying about the math they had just created. Once you start the engine of cosmic inflation, it's almost mathematically impossible to stop it everywhere all at once. Welcome to the theory of eternal inflation. Imagine a vast boiling ocean of space-time expanding exponentially. Within this hyper-expanding ocean, small localized regions will suddenly lose their inflationary energy. They stop expanding at the speed of light, and the stored energy of that expansion is dumped into the creation of matter and radiation. That localized dump of energy is what we call a Big Bang. Our entire visible universe, everything we have ever seen, every star, every galaxy, the billions of light years of deep space is just the inside of one of those localized bubbles where inflation happens to have stopped. But outside the boundary of our bubble, the primordial ocean is still boiling. It is still hyper-expanding, creating vast unimaginable distances between our bubble and the next. And in that boiling void, new bubbles are constantly forming. Billions of new universes are being spawned every single fraction of a second. An infinite foam of realities. The Big Bang was not the beginning of everything. It was just the moment our specific bubble crystallized out of the eternal inflationary sea. Our universe is just one tiny bubble where the inflation stopped, but outside our bubble the ocean is still expanding violently, spawning billions of new universes every fraction of a second. But what do those other bubbles look like? Are they exact copies of us, or are they alien realms of unimaginable physics? The answer lies in the strings. We established in our previous journey that the laws of physics in our universe are perfectly fine-tuned for life. The strength of gravity, the mass of the electron, the power of the nuclear forces, they are balanced on a razor-thin edge. For a long time, this fine-tuning felt like a miracle, but the multiverse offers a chillingly logical and entirely mathematical explanation. It is not a miracle. It is just statistics. When a new bubble universe forms in the eternally inflating ocean, it undergoes a process called symmetry breaking. Think of water freezing into ice. As the water cools, the molecules lock into a crystal structure, but the exact pattern of that crystal, the specific way the ice forms, is different every single time. The early universe was similar. As a new bubble cools and crystallizes out of the inflationary vacuum, the fundamental forces and particles freeze into specific configurations. To understand how many possible configurations there are, we have to look at the leading candidate for the theory of everything, string theory. String theory proposes that the fundamental ingredients of reality are not tiny dots or particles, but unimaginably small vibrating loops of energy. Just as different vibrations on a cello string produce different musical notes, different vibrations of these microscopic quantum strings produce the different particles we see like electrons and quarks. But for the math of string theory to work, the universe cannot just have 3 dimensions of space and 1 of time. The math requires at least 10 or 11 dimensions. We do not see these extra dimensions because they are curled up, folded into microscopic, infinitely complex shapes hidden deep within the fabric of reality. The specific way these extra 6 or 7 dimensions are folded determines exactly how the strings vibrate, and how the strings vibrate determines the fundamental laws of physics for that entire universe. Here is the terrifying part. The mathematics of string theory calculate that there are roughly 10 to the power of 500 different ways to fold those extra dimensions. That is a 1 followed by 500 zeros. It is a number so large that if you wrote a 0 on every single atom in the entire observable universe, you would run out of atoms long before you finished writing the number. This means there are 10 to the power of 500 different possible sets of physical laws. When a new bubble universe is born, it rolls the cosmic dice and randomly selects one of those 10 to the power of 500 configurations. In the vast majority of these bubble universes, the laws of physics are completely hostile. In some, gravity is so strong that the bubble instantly collapses back into a black hole the moment it is born. In others, gravity is so weak that matter never clumps together, and the universe remains a dark, sterile mist forever. In some, electromagnetism does not exist, so there is no light. In others, the strong nuclear force is unstable, so atoms can never form. Billions upon billions of dead, sterile, lightless voids are expanding in the multiverse right now. But if you have an infinite number of bubbles popping into existence over an infinite amount of time, eventually, purely by chance, one of those bubbles will roll the exact combination of physical laws required to create carbon, oxygen, stars, and planets. We are not special. We are simply the statistical inevitability of infinity. We live in the winning lottery ticket because in all the dead universes there is no one around to ask the question. String theory mathematically allows for these unimaginable variations. Most of them are dead, sterile voids. We simply live in the winning lottery ticket. But we thought the multiverse was just out there in deep space, separated by impossible distances of hyper-expanding vacuum. We were wrong. The multiverse isn't just a cosmological structure forming billions of light years away. It is happening right here, right now, every single time you make a choice. To understand how the multiverse is tied to your daily life, we must shrink our perspective from the unimaginable vastness of cosmic inflation down to the smallest possible scale of reality, the subatomic realm, the world of quantum mechanics. In our everyday macroscopic world, objects exist in definite states. A coin is either heads or tails. You're either sitting down or standing up. You cannot be both at the same time. But in the early 20th century, physicists exploring the microscopic building blocks of matter discovered that reality at its core does not behave logically. They found that subatomic particles like electrons and photons do not have fixed positions or states until they are observed or measured. Until that moment of measurement, they exist in a cloud of probability, a state known as quantum superposition, where they occupy all possible states simultaneously. The most famous illustration of this bizarre phenomenon is the thought experiment known as Schrödinger's cat. Imagine a cat placed in a sealed steel box with a radioactive atom, a Geiger counter and a vial of poison gas. If the atom decays, the counter triggers the poison and the cat dies. If the atom does not decay, the cat lives. Because the radioactive decay is a quantum event governed by probability before you open the box, the atom is both decayed and not decayed simultaneously. Therefore, according to the strict mathematics of quantum mechanics, the cat inside the box is both alive and dead at the same exact time. It is only when you open the box and force a measurement that the universe randomly selects one outcome, and the superposition collapses into a single definite reality. This idea that reality is fuzzy until we look at it bothered physicists for decades. It seemed absurd. But in 1957, a brilliant young physicist named Hugh Everett III proposed a radical solution. A solution so paradigm-shattering that it was initially mocked by the scientific establishment, driving Everett out of physics completely. Everett looked at the mathematics of quantum mechanics and asked a simple, terrifying question. What if the wave function never collapses? What if the universe does not randomly choose between heads or tails, alive or dead? What if it chooses both? Everett's theory, known as the many worlds interpretation, states that every single time a quantum event has multiple possible outcomes, the universe literally splits. It branches off into completely separate, independent realities to accommodate every single mathematical possibility. When you open the box to check on the cat reality fractures, in one universe you see a living cat. In another newly created parallel universe, a complete physical copy of you opens the box and sees a dead cat. Both universes are equally real. Both versions of you feel equally conscious. But from that moment on, they can never interact or communicate with each other again. They are forever sealed in separate branching timelines. If Everett's interpretation is correct, and a growing number of modern physicists believe it is, the implications are staggering. Your body is made of trillions of atoms interacting in countless quantum events every millisecond. The electrical signals firing in your brain, the mutations in your DNA, the way photons of light hit your retina. All of these are governed by quantum mechanics. This means that every choice you make, every near miss, every random encounter is a branching point in the multiverse. The universe doesn't force you down one path. It splits reality so that every possible outcome happens, which means floating in this quantum multiverse is a ghost that looks exactly like you. Let us take this concept of the multiverse to its ultimate horrifying logical conclusion. Whether we're talking about the boiling ocean of eternal inflation creating bubble universes or the quantum splitting of many worlds, the underlying mathematical theme is infinity. The human brain evolved to understand finite things, gathering a finite number of apples, surviving a finite number of winters. We are biologically incapable of truly comprehending the concept of forever, but the mathematics of cosmology force us to confront it. Imagine you take a spaceship and travel in a straight line forever. If space is truly infinite, as many cosmological models suggest, then we run into a terrifying paradox involving the arrangement of matter. You're made of a finite number of particles, roughly 7 octillion atoms arranged in a very specific, highly complex pattern that creates your bones, your blood, your brain, and your memories. The observable universe, the bubble we live in, is also finite. It contains a finite number of fundamental particles. There are only so many ways you can arrange a finite number of particles. The number of possible configurations is unimaginably vast, but it is not infinite. Think of it like a deck of cards. There are a huge number of ways to shuffle 52 cards, but eventually if you shuffle them an infinite number of times, the exact same order must repeat. It is a mathematical certainty. If the multiverse is infinite, whether through space or branching timelines, then every possible arrangement of matter must exist not just once, but an infinite number of times. This is not science fiction. This is the cold hard mathematics of probability applied to infinity. Out there in the vast dark ocean of the multiverse, there is an exact copy of this planet, an exact copy of your city, an exact copy of the room you're in right now. And sitting there looking at this exact same screen is an exact physical copy of you. In fact, there is an infinite number of them. But because quantum mechanics allows for variations, there are also infinite versions of you living slightly different lives. There is a universe where you wore a different shirt today. There is a universe where you chose a different career. There is a universe where the asteroid missed Earth 66 million years ago, and hyper-intelligent dinosaurs are building empires. There is a universe where you are the wealthiest person on the planet, and another where you were never born at all. Every mistake you've ever made, every opportunity you missed, every tragedy that broke your heart in another reality, a version of you avoided it. And every lucky break you ever had, every moment of pure joy in another reality, a version of you suffered the opposite fate. Faced with the crushing weight of infinite copies, it is easy to feel entirely insignificant. If everything that can happen does happen, what is the point of our choices? Why does anything matter if an infinite number of versions of you are playing out every possible scenario regardless of what you do? But this is the wrong way to look at the multiverse. The infinity of reality does not devalue your existence. It defines it. Out of all the infinite branching paths of the cosmos, you're experiencing this specific one. The consciousness you feel right now, the memories you hold, the people you love, they belong exclusively to this specific timeline. Your choices do not just dictate your future. They anchor your consciousness to this specific reality. Amidst a storm of infinite possibilities, you are the navigator of your own quantum branch. We are surfing on a branching wave of infinite realities. But there is a glaring problem with all of this. What if the math governing these universes, the quantum branches, the precise codes, the flawless laws of physics are too perfect? What if the reason the universe looks like it was generated by a set of mathematical rules is because it literally was? What if this entire multiverse, the bubble universes, the quantum splitting, the cosmic microwave background isn't physical at all? Next time we boot up the simulation hypothesis, you might want to sit down for that one. Subscribe before your reality glitches. We searched for the ultimate truth in the stars, in the quantum realm, and in the infinite branching multiverse. We looked at the mathematically perfect laws of physics that allow us to exist, and we felt a sense of profound awe. But what if we were looking in the wrong place entirely? What if the universe is not a physical place at all, but a program? Welcome to the ultimate glitch in reality, the simulation hypothesis. For centuries, humanity has assumed that the world around us is made of hard physical matter, rocks, water, flesh and bone. We assumed that if you took a piece of space and cut it in half and then cut it in half again, you could keep doing that forever. A continuous smooth reality. But modern physics has discovered a fatal flaw in that assumption. Space is not smooth, it is pixelated. When physicists try to measure the smallest possible distances and the shortest possible moments in time, they hit a hard limit. This limit is known as the Planck length and the Planck time. The Planck length is unimaginably small, roughly 1.6 times 10 to the power of negative 35 meters. It is so small that if a single atom were the size of the entire visible universe, the Planck length would be the size of a regular tree. But the size is not what is terrifying, it is what the limit represents. According to quantum mechanics, you cannot divide space into anything smaller than the Planck length. It is the absolute fundamental unit of reality. You cannot move a distance shorter than this. You cannot experience a time shorter than the Planck time. If space and time cannot be divided infinitely, it means our universe is not a continuous physical expanse. It is a grid composed of discrete individual units, just like the pixels on the screen you're looking at right now. When you look at a digital photograph from a distance, it looks like a smooth, continuous image. But if you zoom in close enough, the illusion shatters. You see the tiny square pixels that make up the picture. The universe has a maximum resolution. It has a foundational pixel size. Space isn't smooth, it's pixelated. But a pixelated reality needs a processor to render it. And when we look at how the universe renders matter, we find a phenomenon that behaves exactly like a video game engine trying to save memory. Let us move deeper into the code. If the universe is a simulation, it must manage its computational resources efficiently, simulating the exact position, momentum, and spin of every single subatomic particle in the entire cosmos, simultaneously, would require an impossible amount of processing power, even for a machine the size of a galaxy. So how does a computer save memory? It only renders what the player is currently looking at. If you play a massive open-world video game like Grand Theft Auto, the entire city is not fully rendered and existing in the memory of your console all at once. The buildings, the cars, the pedestrians behind your digital character do not actually exist as fully formed three-dimensional objects. They are just mathematical probabilities stored in the code. It is only when you turn your camera around to look at them that the game engine instantly calculates their positions and renders them on your screen. When you turn away, they dissolve back into mathematical potential. For decades, physicists thought this was just a clever trick used by software developers until they performed the double-slit experiment. In this foundational experiment of quantum mechanics, scientists fire individual particles like electrons or photons at a barrier with two tiny slits in it. When no one is watching, the particles do not act like solid bullets. They act like waves of probability passing through both slits simultaneously and creating an interference pattern on the screen behind the barrier. They exist in a state of unrendered potential, but the moment the scientists place a detector at the slits to observe exactly which slit the particle goes through, the wave function instantly collapses. The particle stops acting like a wave of probability and acts like a solid physical bullet passing through only one slit. The universe literally changes its behavior based on whether or not it is being observed. The matter does not take on a definite physical form until a conscious observer or a measuring device forces it to. It is as if the cosmic rendering engine leaves the microscopic world in a state of suspended mathematical blur to save processing power, and only bothers to render the hard physical reality when you zoom in to look at it. The implications are staggering. The chair behind you, the room next door, the stars in the sky. When no one is looking at them, do they really exist as physical objects, or are they just wave functions waiting to be rendered? Albert Einstein himself was deeply troubled by this, asking his colleagues if they truly believed the moon only existed when they looked at it. Quantum mechanics suggests that the answer might be a terrifying yes. Before the double-slit experiment, scientists believed that the universe was deterministic, a giant clockwork mechanism that ticked along regardless of who was watching. But the simulation hypothesis provides a brutally elegant explanation for why quantum mechanics is so weird. In a simulated universe, the laws of physics are not fundamental truths. They are just algorithms. The wave function is just an algorithm designed to calculate probabilities when the system is not being directly observed. The collapse of the wave function is the moment the server allocates processing power to render a specific outcome because an avatar within the simulation requested that data by looking at it. This explains why particles can be entangled over vast distances, communicating instantaneously faster than light. They are not actually traveling across space. They are simply two variables linked within the same line of code in the master program. Changing one instantly changes the other because distance in a simulation is just an illusion created by the software. Reality only renders when you look at it. It is the ultimate cosmic memory saving trick, but every computer has a processing limit, and our universe has a very strict unbreakable speed limit, one that dictates the flow of time itself. Every computer has a maximum speed at which it can process information. This is called the clock speed. In a physical computer on Earth, this is determined by how fast electrons can move through silicon pathways. If the universe is a simulation running on a master computer, it must also have a maximum processing speed, a hard limit to how fast information can travel from one part of the simulation grid to another. We have discovered this limit. We call it the speed of light. Light travels at exactly 299,792 kilometers per second in a vacuum. Not a millimeter faster. For centuries, physicists have accepted this as a fundamental constant of nature, but they have struggled to explain why it is that exact number and why it absolutely cannot be exceeded. Why cannot you simply pump more and more fuel into a spaceship and eventually push it past the speed of light? According to Albert Einstein, as an object approaches the speed of light, its mass becomes infinite, requiring an infinite amount of energy to accelerate it further. The math works perfectly, but the fundamental reason why the universe behaves this way remains a mystery. The simulation hypothesis, however, offers a brutally simple and far more terrifying explanation. The speed of light is simply the maximum clock speed of the cosmic processor. The hardware running our universe cannot transmit information faster than that limit. When you try to accelerate a massive object to the speed of light, you are forcing the simulation to calculate an immense amount of changing positional data across the spatial grid. The system simply cannot handle it. And what happens when a computer is asked to process too much information at once? It lags. It slows down. This is exactly what we observe in the physical universe. We call it time dilation. According to the theory of relativity, time literally slows down for objects moving close to the speed of light relative to a stationary observer. If you fly in a spaceship at 99% of the speed of light for a year and return to Earth, decades will have passed for the people you left behind. Your time slowed down because the processor had to allocate maximum computing resources to render your movement through the grid, leaving fewer resources to render the passage of time for your avatar. Time and space are linked in the simulation software because they share the exact same processing budget. This server lag becomes even more obvious when we look at the most extreme objects in the universe. Black holes. A supermassive black hole is an area where a staggering amount of mass is crushed into an infinitely small point. The gravitational data is so intense that the space-time grid is warped beyond recognition. If you were to watch a probe fall toward the event horizon of a black hole, you would never actually see it cross the threshold. From your perspective, the probe would appear to slow down more and more as it got closer, eventually freezing in place, entirely fading slowly to red. Why? Because the density of information near the singularity is so extreme that the local rendering engine grinds to an absolute halt. The server is completely overloaded by the math required to simulate infinite gravity in a finite space. Time stops at the edge of a black hole because the cosmic computer simply cannot process the next frame of reality. Black holes are the ultimate glitches. They are the blue screens of death in the fabric of space-time where the physics engine breaks down and the code becomes hopelessly corrupted. The speed of light is just the processor limit. Black holes are just server lag. But the most terrifying piece of evidence isn't hidden in extreme physics or the depths of quantum mechanics. It is hidden in the mathematical probability of our own technological future. In 2003, a philosopher from Oxford University named Nick Bostrom published a paper that sent shockwaves through the scientific and philosophical communities. He did not use telescopes or particle accelerators to argue that we live in a simulation. He used simple, undeniable logic. Bostrom proposed the simulation argument, which states that at least one of three specific propositions must be true. Let us walk through them together. Proposition 1. The human species is very likely to go extinct before reaching a posthuman stage. This means we will destroy ourselves with nuclear weapons, rogue artificial intelligence, or climate collapse before we ever develop the technology to run highly realistic simulations of the universe. Proposition 2. Any posthuman civilization is extremely unlikely to run a significant number of simulations of their evolutionary history. This means even if we survive and become gods of technology, we will simply choose not to create conscious simulations of our ancestors because it is deemed unethical or entirely boring. Now, if you believe that humanity will survive its technological adolescence, and if you believe that a hyper-advanced civilization would be interested in running historical simulations for research or entertainment, then you must accept the terrifying mathematical certainty of Proposition 3. We are almost certainly living in a computer simulation right now. Think about the progression of our own technology. 40 years ago, the most advanced video game was Pong, 2 white rectangles bouncing a square dot across a black screen. Today we have photorealistic virtual reality sprawling digital worlds played by millions of people simultaneously, and artificial intelligence that can mimic human conversation perfectly. We're already building primitive simulations. Now imagine human technology 1,000 years from now, or 1,000,000 years from now. A civilization that advanced could harness the energy of an entire star to power a computer the size of a planet. A theoretical machine called a Matryoshka brain. Such a machine would have enough processing power to simulate billions of entire universes down to the quantum level, populated with conscious digital entities that have absolutely no idea they're living inside a program. If the creators can run billions of simulations, then there are billions of simulated realities, and only one single base reality, the physical original universe. Statistically, what are the odds that you, out of all the conscious beings across billions of digital worlds, just happen to be lucky enough to exist in the one true base reality? The math is brutal. It is 1 in billions. It is a mathematical near certainty that we are the simulated ancestors running on the hard drive of a civilization that exists outside our universe. We are not real flesh and blood. We are highly complex lines of code experiencing simulated emotions in a simulated environment, governed by simulated physics. What about the anomalies we experience in our daily lives? The strange feeling of déjà vu where a moment feels exactly like a memory you have already lived. In a computer program, this is exactly what happens when a subroutine is reloaded, or when the server synchronizes data across different nodes. It is a glitch in the rendering process, a momentary stutter in the timeline, as the processor struggles to keep up with the narrative generation. And what about the phenomenon where massive groups of people remember history differently than recorded facts? We call it the Mandela effect, but what if it is simply a patch and update applied to the simulation software by the creators modifying the past data, but leaving residual corrupted memory files in some of the simulated avatars? Every unexplained phenomenon, every ghost story, every paranormal event could just be a minor error in the physics engine of our simulated reality. Does this realization make your life meaningless? If the stars are just digital projections on a cosmic screen, and your memories are just data stored on a hard drive, does any of it matter? Yes, it matters because experience is subjective. Even if the sky is a holographic illusion, the tears you cry are real to you. The love you feel for your family, the pain of loss, the joy of discovery, these are real data points in your conscious experience. A dream is only fake when you wake up. As long as you are inside the simulation, the rules apply and the feelings are entirely genuine. You are a localized node of consciousness experiencing a breathtakingly complex program. We might be lines of code in a cosmic computer. But even code has a purpose. What happens when the simulation ends? Or worse, what if the creators decide they've gathered enough data and it is time to pull the plug? Next time we explore the great filter and the horrifying silence of the cosmos, we will look at the cosmic roadblocks that wipe out entire civilizations and ask the ultimate question: is our time almost up? Hit subscribe and turn on the bell before the server shuts down. We have listened to the stars for decades, expecting a cosmic symphony of alien voices. We have built massive radio dishes pointing them at the darkest corners of the galaxy, waiting for a whisper, a mathematical ping, a sign that we are not alone. Instead, we are met with a deafening, horrifying silence. The universe isn't a peaceful neighborhood, it is an abandoned graveyard, and the killer might still be out there. No matter if our reality is a physical accident, a branching multiverse, or a digital simulation running on a quantum hard drive, there is one undeniable, terrifying observation that haunts every astronomer on Earth. The numbers simply do not make sense. Let us play a game of cosmic statistics. When you look up at the night sky on a clear dark night, you can see maybe 2,000 or 3,000 stars, but that is just our immediate microscopic neighborhood. Our home galaxy, the Milky Way, contains roughly 200 billion stars, and that is just a conservative estimate. Recent data from the Kepler Space Telescope has revealed a staggering truth about those stars. On average, 1 in every 5 Sun-like stars has an Earth-sized planet orbiting within the Goldilocks zone. That is the perfect distance where it is not too hot for water to boil away, and not too cold for it to freeze. Liquid water, the absolute prerequisite for life as we know it, is abundant. Do the math. That means there are roughly 40 billion Earth-like planets in our galaxy alone. 40 billion chances for the cosmic lottery of biology to strike. Now consider the timescale. The universe is 13.8 billion years old. Our solar system is only 4.5 billion years old. This means that there are billions of planets in our galaxy that are billions of years older than Earth. Imagine an alien world that formed just 1 million years before ours. 1 million years is a blink of an eye in cosmic time, but think about human progress. A mere century ago, we were fighting wars with horses and bayonets. Today, we are splitting atoms, mapping the human genome, and sending robotic rovers to Mars. Now extrapolate that technological exponential curve out for 1 million years. A civilization that old would not just be flying in metal ships. They would be engineering the cosmos. They would be building Dyson spheres, massive megastructures that completely enclose a star to harvest 100% of its energy output. They would be manipulating black holes for gravity assists. They would have sent self-replicating probes called von Neumann, probes to every single star system in the galaxy, colonizing the entire Milky Way within a few million years. Their engineering projects would be so massive they would be visible across intergalactic distances. The sky should be crawling with them. We should be seeing the infrared heat signatures of their stellar engines. We should be intercepting their radio chatter or laser communication networks. The Milky Way should look like a bustling, glowing metropolis at night. But when we look out into the dark, we see absolutely nothing. No megastructures, no radio signals, no alien probes, just the cold dead light of natural stars and the static hiss of cosmic background radiation. So where is everybody? This question was famously asked in 1950 by the brilliant physicist Enrico Fermi while walking to lunch with his colleagues. It has become known as the Fermi paradox, and it has given scientists nightmares for over 70 years. The math guarantees we shouldn't be alone. There should be spaceships, Dyson spheres, and galactic empires spanning the Milky Way. So where is everybody? The answer to that question is known as the Fermi paradox, and it points to a concept so deeply unsettling that it makes the threat of a nuclear war look like a minor inconvenience. In 1996, an economist named Robin Hanson proposed a solution to the Fermi paradox. He called it the Great Filter. The concept is brutally simple. Between the formation of a rocky wet planet and the rise of a galaxy-spanning supercivilization, there must be an evolutionary wall, a barrier so incredibly difficult to pass that almost no species ever makes it through. Think of the path to becoming a galactic empire as a long staircase. Step 1 is the right star system. Step 2 is reproductive molecules like RNA. Step 3 is simple single-celled life. Step 4 is complex life. Step 5 is sexual reproduction. Step 6 is multicellular organisms with brains. Step 7 is a tool using civilization like us. And the final step is interstellar colonization. The Great Filter theory suggests that at least one of these steps is a trap, a nearly impossible hurdle that wipes out 99.9% of all intelligent life before they can leave their home planets. The universe is not a nurturing cradle, it is an execution chamber. Countless alien species might have evolved, built cities, looked up at the stars and dreamed of exploring them. And then they hit the filter. They were wiped out by asteroid impacts, gamma-ray burst from dying stars, or perhaps their own runaway technology. The Great Filter is a cosmic executioner that wipes out 99.9% of all intelligent life before they can leave their home planets. But the most terrifying question for humanity isn't whether the filter exists. The question is, are we past it, or is it still waiting for us in the dark? Let us explore the first possibility. The best-case scenario, the Great Filter is behind us. We have already passed the deadliest test the universe has to offer. If this is true, it means that one of the evolutionary steps we've already taken is so miraculously difficult that almost no other planet in the galaxy has ever achieved it. Perhaps it was the very first step. The leap from dead chemicals in a primordial soup to the first self-replicating RNA molecule. We still do not fully understand how life actually began on Earth. It might be an incredibly rare chemical fluke, or perhaps the filter was the leap from simple single-celled organisms like bacteria to complex cells with a nucleus. On Earth, life remained as simple single cells for nearly 2 billion years before complex cells emerged. That is a staggering amount of time. It suggests that complex life is not an inevitable outcome of evolution but a freak accident. If the filter is behind us, it means we are the lucky ones. We are the anomaly out of billions of wet rocky planets. Earth might be the only one where the dice rolled perfectly every single time. It means we are the firstborn children of the Milky Way. We are the pioneers, the torchbearers of consciousness in a vast dead galaxy. It is a lonely thought, but a deeply inspiring one. It means the future is ours to claim. But there is another possibility, and it is the most terrifying thought in the history of science. What if the Great Filter is still ahead of us? What if life is actually very common in the universe? What if single cells and even intelligent animals evolve all the time all across the galaxy? If that is true, then the reason the sky is empty is because something inevitably destroys every advanced civilization before they can colonize the stars. This is why finding simple life on Mars or under the ice of Europa would be the absolute worst news humanity could ever receive. If we dig into the Martian soil tomorrow and find the fossilized remains of ancient bacteria, it would prove that life is not a rare miracle. It would prove that the transition from dead matter to living cells is easy. And if it is easy, then the Great Filter must be in our future. It means the universe is littered with the ruins of dead civilizations that reached our level of technology and then annihilated themselves. What could the future filter be? Perhaps it is the unavoidable discovery of a technology so powerful and so accessible that it guarantees self-destruction, nuclear weapons, artificial superintelligence that turns on its creators, synthetic biology that engineers a perfect unstoppable pandemic, or perhaps civilizations simply exhaust their planetary resources and collapse in a choking greenhouse effect before they can build interstellar ships. We are standing on the edge of a technological precipice and gravity is pulling us down. But there is one final solution to the Fermi paradox, a theory so dark it makes self-destruction look like a peaceful exit. It is called the dark forest theory. Imagine the universe is a dark forest at night. Every civilization is an armed hunter stalking through the trees like a ghost trying to remain completely silent. In this forest, survival is the absolute only goal, but communication across the stars is nearly impossible and resources are finite. If a hunter suddenly hears a noise or sees a campfire in the distance, what do? They cannot risk calling out to see if the other hunter is friendly. The technological gap between civilizations could be millions of years. A friendly greeting could be answered with immediate total annihilation by a weapon we cannot even comprehend. Therefore, the only logical move for any advanced civilization is to instantly destroy any other civilization the moment they reveal their location. It is a preemptive strike to guarantee their own survival. The reason we do not hear anyone in the universe is not because they are dead. It is because they are hiding. They are absolutely terrified, and we, like foolish children lost in the woods, have been broadcasting our radio and television signals into the dark forest for over a century, screaming our exact coordinates to anyone who is listening. We have been sending maps of our solar system on the Voyager probes, hoping to find a friend in the dark. We might have just invited the apex predators of the galaxy to our doorstep. The silence of the universe is not an empty void. It is a warning. We are standing on the most critical threshold in the history of our species. The future of consciousness in this entire sector of the galaxy might depend entirely on whether the apes on this pale blue dot can learn to survive their own technological adolescence. We must navigate the minefield of our own creation without triggering the Great Filter, and without attracting the attention of the hunters in the dark forest. We are alone in the dark forest. But what if the creatures lurking in the dark aren't aliens with spaceships? What if they are shadows of something beyond our physical reality? Next time we break the boundaries of human perception and step beyond the third dimension, we will explore the hidden realms folded into the microscopic fabric of space, where the laws of physics bend and reality shatters. You won't look at reality the same way ever again. Subscribe and prepare to expand your mind. We scan the stars looking for threats in the dark forest. We point our telescopes at distant galaxies, terrified of what might be lurking in the deep cosmic void, but we are looking in the wrong direction entirely. The monsters, the true leviathans of reality, might not be millions of light years away. They might be inches away, hovering right next to you in a direction you physically cannot point to. Welcome to the invisible prison of the third dimension. For your entire life you've existed within a cage so perfectly constructed you do not even realize the bars are there. You can move forward and backward. You can move left and right. You can move up and down. 3 spatial dimensions. This is the entirety of your physical reality. Your brain evolved to track predators and throw spears in a 3-dimensional world, so it literally lacks the biological hardware to comprehend anything outside of that geometric box. But mathematics, the universal language of reality, tells us that our 3-dimensional cage is a microscopic fraction of the true cosmos. To understand our profound blindness, we must imagine a universe far simpler than our own. Imagine a world called Flatland. Flatland is a universe that exists entirely on a 2-dimensional plane, like a perfectly flat sheet of paper, extending infinitely in all directions. The inhabitants of Flatland are living geometric shapes, squares, triangles, and circles sliding around on the surface. They have length and width, but absolutely no height. For a Flatlander, the concept of up or down is not just physically impossible, it is cognitively unimaginable. Now imagine you, a 3-dimensional human, decide to visit Flatland. You reach out and poke your finger through their 2-dimensional universe. What do the Flatlanders see? They cannot see your hand or your arm. They cannot look up to see your face, because up does not exist for them. They only see the 2-dimensional cross-section of your finger, where it intersects their plane. To them, a circle suddenly miraculously appears out of nowhere, defying all their known laws of physics and the conservation of mass. If you push your finger further through, the circle grows larger. If you pull it out, the circle shrinks and vanishes into nothingness. If you were to speak to a Flatlander, your voice would seem to resonate from everywhere and nowhere at once, originating from a spatial direction they cannot even conceptualize. To a Flatlander, you are a god. You possess the power of spontaneous creation and destruction. You can see inside their locked safes and inside their very bodies, because from your higher dimension, their 2-dimensional interiors are completely exposed from above. But you are not a god. You just have access to one more dimension than they do. Now elevate that terrifying thought experiment to our reality. We are the Flatlanders. We are biological geometric shapes sliding around on a three-dimensional plane trapped in our limited perception. If a four-dimensional hyper-object were to pass through our universe, we would not see its true form. We would only see a three-dimensional cross-section mutating, shifting, and appearing out of thin air. It would look like magic. It would look like a miracle. Or it would look like an unsolvable anomaly in quantum physics. We confidently declare that we understand the universe based on what we can see, but what if the vast majority of reality is happening just out of sight, hovering in a spatial direction our brains cannot render? To a 2D creature, a 3D object is a god defying the laws of physics, but we are not the gods. We are the flatlanders, and right now higher dimensional forces are passing through our world, appearing to us as inexplicable scientific anomalies. Let us revisit one of the most glaring, terrifying anomalies in all of physics, the unbearable weakness of gravity. As we established earlier, a tiny refrigerator magnet can easily overpower the gravitational pull of the entire planet Earth. Why is the force that holds the cosmos together so pathetically weak compared to electromagnetism or the nuclear forces? For decades, this question baffled the greatest minds on Earth until they started thinking outside the three-dimensional box. Theoretical physicists developed a framework known as brane cosmology, derived from the mathematics of string theory. Imagine that our entire visible universe, the billions of galaxies, the expanding void, the cosmic microwave background is not the entirety of space. Instead, our three-dimensional universe is just a thin membrane or a brane floating within a much larger higher dimensional space called the bulk. Think of a single slice of bread within a massive loaf. We are trapped on the slice, the light. We see the particles, we interact with the atoms that make up your body, are all permanently glued to this three-dimensional membrane. We cannot look off the slice. We cannot shine a light into the bulk because photons of light are also trapped on our brain. But gravity is different. According to this theory, gravity is the only fundamental force that is not confined to our three-dimensional prison. It exists in the bulk. It is a higher dimensional force. The reason gravity appears so incredibly weak to us is not because it is actually weak. It is because the vast majority of its strength is leaking off our membrane and bleeding out into the extra dimensions. We are only experiencing a tiny diluted fraction of gravity's true power, the ghost of a force that is far more terrifying in its full multidimensional reality. Gravity isn't weak. It is simply diluted across dimensions we cannot see. But if gravity can leak out of our universe what is leaking in, the answer to that question might solve the most terrifying mystery of modern astronomy. When astronomers look at the spinning galaxies scattered across the cosmos, they encounter a massive mathematical deficit. There is simply not enough visible matter, not enough stars, gas or dust to generate the gravity required to hold these galaxies together. They should fly apart. To fix the math, scientists invented a placeholder, a ghost. They called it dark matter. It supposedly makes up 85% of all the mass in the universe, yet it is completely invisible. It does not reflect light. It does not block light. It does not interact with electromagnetism at all. It only interacts through gravity. For decades, we've built massive underground detectors hoping to catch a single particle of dark matter, but we have found absolutely nothing. What if the reason we cannot find dark matter particles in our universe is because they are not in our universe at all? Let us apply the logic of brane cosmology. If gravity can leak out of our membrane into the higher dimensional bulk, then gravity from other membranes can also leak into ours. Imagine there is another three-dimensional universe, another slice of bread floating in the bulk just a fraction of a millimeter away from ours, along a fourth spatial dimension. We cannot see it because light cannot travel across the bulk between the membranes. It is completely invisible to us, but gravity can cross the gap. What if the dark matter we detect holding our galaxies together is actually the gravitational shadow of massive structures in that parallel universe? When we measure dark matter, we might be feeling the gravitational pull of a parallel galaxy, an alien star system, or even an invisible hyperdimensional planet pressing against the fabric of our reality from the other side. A ghost world hovering inches away from your face, separated by a dimensional wall you can never cross. We are feeling the weight of the unseen. Dark matter isn't an invisible particle. It is the gravitational footprint of a parallel universe pressing against our own. A ghost world we can feel but never touch. To understand how these worlds are structured, we must look at the ultimate architecture of reality. To understand the ultimate architecture of reality, we must dive into the most complex mathematical framework ever conceived by the human mind, M-theory. In the 1990s, physicists realized that the various competing versions of string theory were actually just different perspectives of one single underlying master theory. But this master theory demanded a terrifying price. It required exactly 11 dimensions to function perfectly. One dimension of time, 3 dimensions of space that we experience every day. But where are the other 7 spatial dimensions? Why do we only see 3? The mathematics of M-theory suggests an answer so bizarre it challenges the very limits of human imagination. The extra 7 dimensions are not massive parallel universes like the bulk. They are microscopic. They are curled up and folded into themselves at scales so unimaginably small that we cannot detect them even with our most powerful particle accelerators. Imagine looking at a telephone wire from a great distance. It looks like a one-dimensional line. You can only perceive length. But if you walk closer, or if you are a tiny ant crawling on that wire, you realize it is actually 3-dimensional. You can crawl around the circumference of the wire. The extra dimensions are there, but they are simply too small to see from afar. The extra 7 dimensions of our universe are folded into incredibly complex microscopic geometric shapes, called Calabi-Yau manifolds. These manifolds exist at every single point in space. Right now, in the seemingly empty air in front of your face, inside every atom of your body, there are billions of these microscopic multidimensional structures. And here is the true miracle of this mathematical symphony. The exact shape, the precise microscopic geometry of how these 7 extra dimensions are folded determines the vibrational patterns of the fundamental strings of energy trapped within them, just as the physical shape of a brass trumpet dictates the exact musical note it can play. The geometric folding of these hidden dimensions determines the fundamental properties of all matter and energy in our universe. The mass of an electron, the exact strength of a magnetic field, the specific decay rate of a radioactive particle, all of these are dictated by the invisible microscopic architecture of higher dimensional space. The macroscopic universe, you see the glowing stars, the orbiting planets. Your own beating heart is nothing more than a cosmic shadow. A massive 3-dimensional projection cast by vibrating strings hidden inside an 11-dimensional symphony. We are prisoners of the 3rd dimension. Our biological eyes are blind to the true vastness of reality, locked forever inside a 3-dimensional cage of physical perception. But this blindness is not a weakness. It is the ultimate testament to the terrifying power of human consciousness. Even though our fragile bodies are trapped on a membrane, we've developed a 6th sense capable of piercing the dimensional veil. Mathematics. Through pure equations and rigorous logic, the human mind has managed to step outside of its biological prison and map the invisible architecture of creation. We have heard the 11-dimensional symphony. We are prisoners of the 3rd dimension, blind to the true vastness of reality. But eventually all structures, even 11-dimensional ones, must face the ultimate end. What happens when the universe runs out of time completely? When the last star dies and the black holes evaporate, does the symphony just stop forever? In our grand finale, we will witness the rebirth of everything. The Boltzmann brain and the eternal cycle. Subscribe because you do not want to miss the end and the terrifying new beginning. We thought the heat death was the final chapter of our universe. Absolute zero, eternal darkness. But in the terrifying mathematics of quantum mechanics, nothing is actually the most unstable state of all. The end of time is just a reset button. But before we can understand the rebirth, we must first endure the agonizing, meticulously slow death of everything we know. Look around you. The universe seems dynamic and vibrant. Stars are burning, galaxies are spinning, and life is flourishing on our tiny blue rock. But this era, the stelliferous era, is just a fleeting spark in the true timeline of the cosmos. Fast forward 100 trillion years into the future. Long after humanity has either transcended or gone extinct, the universe will become unrecognizable. The process of star formation will permanently cease. The giant clouds of interstellar gas and dust, the nurseries that birth new stars, will be completely exhausted. The night sky will begin to slowly, inevitably go dark. The massive blue and white stars will die first, exploding in brilliant supernovas, leaving behind black holes and neutron stars. Then the sun-like stars will quietly puff away their outer layers, leaving behind glowing embers called white dwarfs. Finally, the only stars left will be the red dwarfs. Tiny cool stars that burn their fuel so slowly they can live for trillions of years. But even they are not immortal. Eventually, the last red dwarf in the entire cosmos will consume its final atom of hydrogen. It will flicker and die, fading into a cold black dwarf. The lights of the universe will be turned off. This marks the beginning of the degenerate era. The universe will be a graveyard of dead stars, black holes, and rogue planets wandering blindly through a pitch black, freezing void. But the relentless march of Entropy, the dictator we spoke of at the very beginning of our journey, is not finished yet. Over timescales so incomprehensibly vast that the human mind simply shatters, trying to picture them, even the dead matter will begin to fail. According to the grand unified theories of physics, the very building blocks of matter, the protons that make up the nuclei of every atom in your body and every rock in the universe, are fundamentally unstable. They have a half-life. Wait a few undecillion years, that is one followed by 36 zeros, and the protons themselves will begin to decay. The dead stars and frozen planets will literally dissolve at the subatomic level, turning into a fine mist of radiation and light particles. The physical structures of the universe will simply melt away into the dark. By the time we reach a Google, years into the future, a 1 followed by 100 zeros, we enter the black hole era. The only macroscopic objects left in the entire infinite expanse of the universe will be the supermassive black holes. The monsters in the dark that once orchestrated the birth of galaxies will now rule over an empire of absolute nothingness. But remember, the universe despises order, and even a black hole is a highly ordered gravitational structure. Through a quantum mechanical process discovered by Stephen Hawking known as Hawking radiation, these invisible leviathans will slowly begin to leak energy. Particle by particle, photon by photon, they will evaporate into the void. It will take an unimaginable amount of time, but eventually even the most massive black hole in existence will shrink down to a microscopic point and vanish in a silent final flash of energy. And then there is nothing. We have reached the dark era. All matter has decayed. All black holes have evaporated. The universe is nothing but a thin, almost infinitely diluted sea of lonely photons and subatomic particles drifting through a freezing, expanding void. The temperature of the cosmos plunges to absolute zero. Everything that can happen has happened. The story is over, but when matter completely dissolves and there are no structures left to change state, something incredibly profound and terrifying happens to the fabric of reality itself. Time stops. Think about what time actually is. Time is simply a measurement of change, the ticking of a clock, the orbit of a planet, the decay of an atom. If the universe reaches a state of maximum entropy, where absolutely nothing changes from one moment to the next, then the concept of time loses all physical meaning. There is no past because the past looks exactly like the present. There is no future because the future will be identical to this exact moment. A trillion years passing feels exactly the same as a single second. Furthermore, distance also vanishes. Without solid objects to act as reference points, without stars or galaxies to measure the space between them, the concept of size becomes entirely irrelevant. An infinite void is mathematically indistinguishable from a microscopic dot. Time stops when nothing happens. Distance vanishes when there is nothing to measure. But quantum mechanics dictates that a completely empty vacuum cannot exist forever. A dead universe is a loaded cosmic gun waiting to fire. This brings us to one of the most mind-bending theories in modern cosmology proposed by the Nobel laureate Sir Roger Penrose. It is called conformal cyclic cosmology. Penrose noticed a terrifying mathematical symmetry at the absolute end of time. As we established, when the universe reaches the dark era, there is no mass left. The only things remaining are massless particles like photons of light travelling through an infinite void. According to the theory of relativity, massless particles do not experience time and they do not experience distance. To a photon, the journey from one side of the universe to the other takes 0 seconds, because the entire universe is now filled only with particles that do not experience scale or time. The universe itself literally forgets how big it is. It forgets how long it has been expanding. And here is where the mathematics reveal a stunning twist. If you take a universe that has expanded into an infinitely large, infinitely cold void, where time and space have lost all physical meaning, the mathematical equations describing that state are completely indistinguishable from the equations describing the infinitely dense, infinitely hot singularity that existed the exact moment before our Big Bang. Let that sink in for a moment. The ultimate freezing end of our universe is mathematically identical to the fiery microscopic beginning of a new one. The end is the beginning. Penrose suggests that our Big Bang was not the absolute start of everything. It was simply the beginning of our specific eon. When a universe dies and loses its concept of scale, the infinite void essentially becomes a new singularity, triggering a new Big Bang. Our universe is just one breath in an eternal cosmic lung, expanding, dying and rebirthing itself in an endless, flawless cycle. Our Big Bang wasn't the first. It was just the latest breath of an eternal cosmic lung. But if the universe repeats itself infinitely over infinite eons, it creates a statistical nightmare for your own existence. If time is truly infinite, stretching out forever across endless cycles of dead universes, we run into a paradox so horrifying it has kept physicists awake at night for over a century. It is called the Boltzmann brain paradox, named after the brilliant 19th century physicist Ludwig Boltzmann. Let us look at the sheer, staggering probability of your existence. For you to be sitting here watching this documentary, it took 13.8 billion years of perfectly tuned physical laws. It took billions of giant stars exploding in violent supernovas to forge the heavy elements like carbon and iron required for your biology. It took billions of years of brutal, unforgiving biological evolution on a wet rock orbiting a yellow dwarf star. Statistically speaking, the natural evolution of a conscious human brain requires a ridiculously complex and unlikely sequence of events. But in the infinite expanse of a dead universe, quantum fluctuations still happen. The vacuum of space is never completely empty. Tiny random particles constantly pop in and out of existence, borrowing energy from the void and returning it almost instantly. Given an infinite amount of time, probability dictates that these random quantum fluctuations will eventually assemble themselves into every conceivable structure purely by chance. Imagine monkeys typing on a typewriter for infinity. Eventually they will type the complete works of Shakespeare by pure accident. The universe works the same way. Over an infinite span of dead time, random atoms will assemble into a rock. They will assemble into a chair, and eventually they will assemble into a fully functioning human brain. The mathematics of probability are clear and brutal. The chance of random quantum fluctuations assembling a fully formed human brain floating in the pure vacuum of space, complete with false memories of a childhood, a life on Earth, and the specific experience of watching this exact video right now, is vastly mathematically higher than the probability of a real 13.8 billion-year-old universe evolving naturally to produce you. The math is clear and horrifying. Statistically, it is infinitely more likely that you are a momentary glitch floating in the void, hallucinating this entire documentary than a real human sitting on Earth. You are a Boltzmann brain. Your friends, your family, the device you're looking at, the room you're sitting in, none of it is real. It is all a brief firing of neurons in a disembodied brain that popped into existence a fraction of a second ago and will freeze to death in the cold vacuum of space a fraction of a second from now. So are you real? So are you real? Does it matter if you're a Boltzmann brain hallucinating in the freezing void? Does it matter if you are a line of code in an ancestral simulation running on a posthuman hard drive? Does it matter if you're a three-dimensional shadow cast by an 11-dimensional symphony of vibrating strings, or if you are just one of an infinite number of branching copies in a quantum multiverse? After peeling back all the layers of reality from the violent spin of the early cosmos to the dark forest of the great silence, we're left with only one undeniable absolute truth. I think, therefore, I am. The philosopher René Descartes wrote those words centuries ago, and they remain the only anchor we have in a universe of infinite, terrifying possibilities. Your experience is real, even if the stars are holograms and your memories are quantum glitches. The pain you feel, the love you share, and the curiosity that drove you to seek the answers to these ultimate questions are entirely genuine to you. The universe began as a chaotic soup of dead energy. It expanded, it cooled, and it formed beautiful but mindless structures. For billions of years, the cosmos was deaf, dumb, and blind. It was only when matter arranged itself into the intricate wet wiring of a brain that the universe finally woke up. You are not just a passive observer standing outside the universe looking in. You are a localized node of the universe itself. You are the cosmos experiencing its own majesty, its own terror, and its own breathtaking beauty. The act of asking why is the highest function of reality. You are the ultimate defiance against the meaningless void. Out of the chaos and the dark matter, the quantum glitches and the infinite loops matter woke up. We have reached the end of everything only to find a new beginning. We have travelled from the first violent spin of creation to the silent evaporation of the last black hole, and finally back to the spark of your own consciousness. If this journey expanded your mind, if it made you question the very nature of reality, hit subscribe like this video and share it with someone who needs an existential wake-up call. The universe is vast, terrifying, and beautiful, and our journey to understand it is just beginning. I will see you in the next Aeon.